Did you know that zippers can withstand a force equivalent to the weight of 500 elephants? Zippers are ubiquitous in our daily lives, from clothing to bags, but have you ever stopped to think about the fascinating mathematical patterns behind their design and functionality? For centuries, humans have been fascinated by the intricate mechanisms that govern the way zippers work. And in this video, we'll delve into the fascinating world of mathematical patterns in everyday life, focusing on the humble zipper. From the clever use of geometry to the clever application of physics, we'll explore the remarkable story of how zippers have evolved over time to become the reliable and convenient fasteners we know today. So let's start with the basics. What is a zipper and how does it work? A zipper is essentially a series of interlocking teeth connected by a chain or strip of fabric, with each tooth having a small hook or catch that engages with the corresponding tooth on the other side. When you pull the zipper, the hooks and catches interact, allowing the teeth to slide past each other and the zipper to move up or down. But here's the interesting part. The geometry of the zipper's teeth is crucial to its functionality. Imagine a zipper as a series of interconnected gears, where each tooth is a gear that turns as the zipper moves. The shape and size of the teeth determine the angle at which the gears interact, which in turn affects the force required to move the zipper, creating a stress wave that can cause the zipper to jam or even break.
As you pull the zipper, the stress builds up in certain areas, creating a stress wave that can cause the zipper to jam or even break.
The stress wave created by the zipper's geometry is an excellent example of a nonlinear phenomenon, where small changes in the input, pulling the zipper, result in large changes in the output, the stress wave. This nonlinearity is a hallmark of complex systems, and it's exactly this kind of behavior that mathematicians and physicists are eager to understand. In fact, the study of nonlinear systems has led to some groundbreaking discoveries, including the development of chaos theory and the understanding of complex phenomena like turbulence. But what about the physics behind the zipper's movement? As you pull the zipper, you're essentially creating a tension in the chain or strip of fabric that connects the teeth. This tension is what allows the zipper to move, and it's also what causes the stress wave to build up along the length of the zipper. The interesting thing about this tension is that it's not just a simple linear relationship between the force applied and the distance moved.
Instead, the tension follows a more complex pattern, known as a force displacement curve, which is a classic example of a nonlinear relationship.
The zipper's geometry and physics have a significant impact on its reliability and performance. In fact, the stress wave created by the zipper's geometry can cause it to jam or break, especially when subjected to heavy use or stress. This is why manufacturers often use specialized materials and designs to mitigate the effects of the stress wave. So, what can we learn from this fascinating story of mathematical patterns in everyday life? Firstly, we see how geometry and physics come together to create a complex system that's both beautiful and functional. Secondly, we're reminded of the importance of understanding nonlinear phenomena, which are all around us in the natural world. And thirdly, we're inspired by the ingenuity of humans, who have designed and engineered the zipper to be a reliable and convenient fastener. So, the next time you zip up your jacket or pull your luggage, remember the fascinating mathematical patterns at play. If you found this video fascinating, subscribe for more incredible stories like this. And don't forget to like and comment below to let me know what you thought. Want more mind-blowing facts? Hit subscribe and join our journey of discovery.